Well, I'm going to go ahead and get us started here. People can continue to join. We'll just do some of the introductions to start off with. So I'm Lisa Austin, and I'm with MnDOT in the Center for Community Connections. And I am the current chair of the CTS Research Council on Transportation Planning and the Economy. So before we get started on the presentation, I'll just give you a little bit of background on CTS. So CTS stands for the Center for Transportation Studies, and it's part of the University of Minnesota. The councils are designed to get transportation professionals, researchers, and practitioners, and from both the public and private sector together to discuss and learn about research and work together on upcoming problem statements and learn about existing research, education, and engagement. So they're a great opportunity to network and get to know each other. Sam will put a link to the CTS Research Council structure in the chat. So if you want to learn a little bit more about all the other councils, the transportation planning and the economy is just one of the many councils that are part of CTS. So today our featured speaker is a group of folks talking about a group of folks presenting on some research that's part of the Transit Impacts Research Program, the TIRP program. And again, it's brand new research, so they'll be going over some of the findings of the impacts of dedicated right-of-way and on transit ridership and carbon emissions. So how does having a dedicated right-of-way affect ridership and some of the climate change issues? Before we get into all that, though, I do want to have a chance to thank our outgoing chair, Mary Carlson. So just a little bit of what this means. Leadership of the councils, the chair and the vice chair positions, it's a 6-year commitment. So for the first 3 years, you're vice chair, and then the next 3 years, you're chair. So I can't believe it's been 3 years. It seems like just yesterday when I was meeting Mary for the first time and learning about what it would take to help be part of leadership with the council. Thinking about that 6-year commitment, we really want to thank Mary for all her time. And, she's been such a great role model in leadership of the council. She's got such great perspectives, such a curious mind, really interested in all topics that fall under this theme. She was always good at really reminding us to balance topics. Sometimes there's the, popular things like CAV or bike ped or, some of the emerging things that are coming out, but she always kept us grounded in having, let's think about everything that falls under this umbrella. Have we had a topic on freight recently, or, economic development, so just making sure that we were balancing it. And again, just really smart questions, very thoughtful, very analytical, and very practical. Like how is this research going to impact how we do our work? So, just like I said, a great role model. Really, she knows everybody, so was good at recommending speakers and members of the council. So again, just want to thank her a lot. I look back on the 3 years, through that leadership time, we had to pivot to virtual meetings. That's right at the start of COVID, and now that's changed kind of how we do all the meetings. A lot of the meetings are virtual, where they used to be all in person, and that's got its benefits in how we see a much larger rate of participation, not just in the metro but all over Minnesota and in the country. So her leadership, along with the CTF staff, really made that a positive change. We also lived kind of near each other, so during COVID, we were able to, talk about CTS and get to know each other by taking walks in the neighborhood. So I not only got to know a great colleague, but also a new friend. So I don't know, Mary, if you want to say a few words, if you're on the line, I know you were planning to join. We can unmute you and you can say a few things if you'd like.
Hey, Lisa, can you hear me?
I sure can.
Hey, everybody. Thank you so much for being with us today. I just want to give a huge thank you to the Center for Transportation Studies, to you, Lisa, to Jonathan Ehrlich, who was the predecessor before I was chairing the group. This has been the honor of my lifetime to be part of CTS. I just am such a fan of the important work that we're doing. And, again, like Lisa said, we navigated the time through COVID and, are here online together. And we acknowledge that that is not the same as sitting in person. But also, I just want to say thank you for being brave. Thank you for being committed to our work. And thank you for being inclusive. One of the things that we see and we've measured with numbers is that because we do these webinars online, we have a greater impact and we have more folks participating from greater Minnesota as well as from the metro area. And for me, that is the number one thing that I'm so proud of during the time that was my tenure, is that we have welcomed the Mille Lacs Band of Ojibwe to our meetings. We have welcomed numbers of people from greater Minnesota, from Rochester, from Duluth, from northwestern Minnesota. And together, I truly believe that we are stronger. So again, thank you so much. Keep doing awesome work.
Oh, thanks again, Mary. Great thoughts and great reflections. So now I have a chance to introduce the new vice chair since I've moved into the chair role. So as much as I'm going to miss Mary, I'm very excited to work with Paul Morris. Paul has been a very dedicated supporter of CTS. I always see him at the annual meetings. He's always attending various council meetings. He participates in the meetings, asks good questions. He's got such a keen interest in research. And we've worked together on a few projects in the past, so I've known him for quite a while. So I am really excited to have Paul Morris by my side for the next 3 years while I'm the chair. And I'm going to turn it over to Paul now to tell you a little bit about himself and to take care of a few more housekeeping things before we get into the presentation.
All right. Well, thank you so much, Lisa and Mary. Appreciate the kind introduction and want to recognize you for your service to the council as well. I'm very excited to be part of this incoming vice chair role, and would just note that CTS has been a big part of my career, going all the way back to being a graduate student at the University of Minnesota. Just to cover a couple of housekeeping items for us here today. One of the things we're really excited about with this webinar format is the opportunity to have an interactive and engaging discussion. So we welcome any comments or questions along the way. Please do that by using the Q&A or chat feature at the bottom of the screen here. And you can certainly enter those Q&A comments throughout the presentation, and then at appropriate times we will stop and read those aloud for the group. When we reach the end of the presentation, we also do have time set aside for additional discussion, at which time you can raise your hand and we'll unmute you if you'd like to address the group here. I'd also note that this event is intended to meet professional development hour requirements for planners and engineers, if I'm not mistaken. So if you would like a certificate for that, please enter a chat to the panelists, and a PDH form will be provided to you here. This is also my opportunity to plug some of the upcoming events. CTS has a very busy fall season scheduled here. There are 3 more webinars coming up over the next couple of months here. On Tuesday, October 10th, there will be a webinar on evaluating options for wastewater treatment at rest areas and truck stations. So I hope you can join for that. On Wednesday, November 8th, pavement marking and colored pavement friction differential and product durability. And finally, on the 20th, towards implementation of max pressure signal timing on Minnesota roads. I do want to emphasize all of those events are free, but you do have to register. So please go to the CTS website and you can sign up for those to get your webinar link to join those meetings. And certainly we can't leave off the CTS Transportation Research Conference, really the flagship event coming up, as it always is, in the beginning of November. So that'll be on Thursday, November 2nd this year. And I want to highlight that there is a change of location to that event. This year, it will be held at Kauffman Memorial Union at the University of Minnesota. So when you register and show up for that event, just make sure you're coming to the right location. And we look forward to seeing you there. The last thing, just wanted to note, we always welcome current students that are participating in today's activity. If you are a student, we'd like you to enter your name into the chat, and that way we can just keep track of students that have joined, as of course we look forward to the next generation of transportation professionals being part of these activities. So thanks very much, and I'll turn it back to Lisa.
Great, thanks, Paul. All right, so with all these thank yous and recognition, a couple more people that we want to highlight here are Gina Boss and Sam Hahn DeVille. They're with CTS and have put together today's webinar. You know, they make Paul's and my job very easy, being the chair and vice chair, and make everything run smoothly and help us select presenters and whatnot. So thanks again to Gina and Sam. All right, so today's webinar focuses on an overview of the TIRP research program, like I described before. TIRP was launched in 2006, and it really works to study the contributions of transit on mobility, economic development, job access, equity, opportunity, well-being, safety, sustainability, all that. So, you know, a lot of other things look at other parts of transportation, but this program really looks at transit impacts. So today, the presenters will share highlights from their recent TIRP-funded project. And like I said before, it's on the dedicated right-of-way for transit systems. So it looks at, you know, how does that impact ridership? How does that impact carbon emissions? And this is a pretty hot topic right now. There's a number of corridors where people are suggesting or looking at, you know, dedicated lanes for transit. And you think about dedicated right away, it could be light rail, it could be BRT, it could be, you know, bus only shoulders, you know, dedicated lanes. I mean, there's different ways of looking at the dedicated right away. So yeah, you know, other transits in mixed traffic and, you know, other ways. So there's not a lot of research on this. So today they'll, you know, share what they've been able to find out. So our speakers today are Eric Lind, who's the director of the Accessibility Observatory at CTS, Jason Cow, who's the professor, is a professor at the Humphrey School, and Tao Tao, a postdoctoral research associate at the Mobility Data Analytics Center at Carnegie Mellon University. And then from a practitioner's perspective, we have John Levin from Metro Transit, who's the director of strategic initiatives. So it should be a well-rounded discussion with that practitioner's perspective at the end. So with that, I'm going to pass it on to Eric. So thank you. Thanks for everyone for being here.
Thanks, Lisa. I'm going to up some slides. So a little bit of the background today. I'll just say that I am taking over within CTS for a longstanding and much beloved member of CTS, who is Don Hood, who has left for another position in the university. Among the many things that Don did here was help administer and coordinate the TIRP program. And so myself and Beth Andrews have tried to take that over, and we're trying to fill some very big shoes making that happen. So my role today is really to give a really brief overview of TIRP, kind of extending what Lisa just mentioned, and then also introduce this particular project that we're going to hear about today. So as described, the TIRP name stands for Transit Impacts Research Program, but it began, if I can advance, began as the Transit Way Investment Research Program when it was a collaborative effort among counties and the Met Council way back in 2006. And as Lisa mentioned, it has a lot of different angles to understanding the impacts of transitways and now transit. But the way the program has evolved has sort of moved from being about how do we plan and understand the impacts of these transitways of the future, to now here we are where these transitways have, at least in part, been constructed. How are they best going to be operated? How are they best going to be extended, coordinated across jurisdictions and so forth? So the program has evolved as the region's transit research needs have evolved, and that's one of its strengths for sure. So to be a little specific about the coordination, these are the current contributors, the counties of Hennepin, Ramsey, and Washington, together with the Met Council, MnDOT through their research area, as well as us at the University of Minnesota through CTS. And it's a collaborative program in terms of identifying research needs, and it's collaborative in terms of funding that research. And all of these parties contribute to being able to find and support the researchers, like the ones you're going to hear about today, in answering these questions that are of need to practitioners and policymakers. So as an example of some previous work that some of you may remember, TIRP programs have looked at things like the economic benefits of transitways and running transit. When you look at a scan of regions in the country, what are some of the economic impacts of having these transitways? Looked at things like what are the changes in access to opportunity that will be provided by new transit service, looking at how residents could get to more opportunities or get to the same number faster with these new transitway lines. And again, with MnDOT's cooperation as well, there's always interest in how transitways are interacting with roadway operations, whether you're talking about parallel dedicated guideway rail projects or BRT, the arterial system running in mixed traffic. We've studied these types of questions as well inside the TIRP program. So the way this works is that the counties and Met Council, we get together and brainstorm and identify what are the research priority needs. And as Lisa mentioned, one of the hot topics recently has been this idea of dedicated right-of-way. So allocating street space to transit, either in different forms of dedication, whether it might be a temporary bus lane, a full-time bus lane, separated guideway. You'll hear more about this from the researchers. But this right-of-way or ROW, what the research need was to identify what is the value or benefit of these types of investments to transit and to the broader economic condition of transportation. So the first cut at this we'll hear about today from Jason and Tao, which is about kind of a scan of what this looks like at a high level in terms of impacts on ridership and on through ridership, what carbon emission reduction we can see, as well as identifying how these different types of rights-of-way interact with other aspects of transit provision. There's a second half to this research, which maybe we'll hear about later on in a different webinar. It's research that's in progress under the MnDOT funding umbrella with Ying Song and Alireza Khani, who are leading more of an operational benefits and operational strategies investigation into kind of where, when, and how these dedicated rights-of-way are most effective and how they should be applied. So you can look forward to that research down the road, but today we're going to hear from Jason and Tao about what they've discovered in terms of the benefits of dedicated right-of-way for transit in their research. So I will turn it over to them.
Thanks, Eric. So I'm first going to share my slides. Hi, everyone. My name is Tao. So the work is led by Professor Jason Kao, and we also have two very excellent research assistants who are Isaac Johnson and Hannah Huang. The topic of this study again is the value of dedicated right-of-way to transit ridership and carbon emissions. So what is dedicated right-of-way? So dedicated right-of-way, which means the right-of-way is dedicated for a certain travel mode. For this study, actually, we focus on the dedicated right-of-way for transit. Some background. So dedicated transit is a very important tool to develop an environment-friendly transportation system. Dedicated right-of-way for the transit has been used to improve the service quality and the ridership performance of the transit routes. while it seems intuitive that dedicated right-of-way is useful in increasing ridership and reducing emissions, very few studies have empirically quantified how much impact of dedicated right-of-way could have on transit ridership and on transit ridership and emissions. So that's why we have this project. The project is trying to estimate the value of dedicated right-of-way in increasing transit ridership and reducing carbon emissions. Based on the transit capacity and the quality of service menu, third version, we define 4 types of right-of-way, which is also used as operating environment in this project. Sometimes I will use operating environment instead of right-of-way, but they are the same concept. So the first type is mixed traffic. So which means the transit and the other travel modes share traffic lanes during all time. This is the most common right-of-way for transit. About 98% of the transit route in the US use this type of right-of-way. And the second is semi-exclusive. It means that certain modes are allowed at certain locations and or during certain times. For example, vehicles on freeway managed lanes, cyclists and pedestrians on transitways, 20 vehicle parking lanes during non-peak hours. The third type is exclusive operating environment, which means other modes are only allowed at grade crossing. The last type is grade separation. It means transit routes are operated underground or on elevated lanes, and other modes are completely excluded, which means the lane is only for transit routes. So in this study, we will regard exclusive operating environment and grade separation operating environment as dedicated right-of-way. So there is a pattern here, which is from the mixed traffic to semi-exclusive to exclusive, and finally to grade separation. The operating environment has less and less impact from other traffic. A brief introduction of the literature review. So based on the literature review, dedicated right-of-way have the potential to reduce travel time and improve speed, reliability, capacity, visibility, and boost economic development. At the same time, dedicated right-of-way also have some cost. The first is its construction cost is very high, and it will use a lot of space, including lanes and parking space. It also may be perceived as being underused because of low volumes. So based on the literature, there exist very few studies on the impact of dedicated right-of-way on transit ridership and related emissions. So that's why we have this study. So to empirically study or empirically quantify the impact of dedicated right-of-way on transit ridership and related carbon reductions, we first send a survey to local transit agencies about the characteristics of the transit routes they operate. In this study, we focus on light rail and BRT. After sending requests to the local transit agencies across the US, we have collected the information of 78 transit routes, including 20 light rail or streetcar routes, and 58 BRT routes or bus transit sharing some features with BRT. These transit routes are operated by 31 transit agencies located in 24 CBSAs. CBSA is census-based statistical areas. In this map, we showed all the locations of all the transit agencies that operate LRT or BRT. The blue area shows the locations where the transit agencies operated a LRT and a BRT, and those LRT and BRT have been included in our analysis. And for the gray areas, those BRT and LRT are not included in our analysis. So in this study, we will use 6 types of variables related to transit route. For the survey, we can have 3 types of variables from the survey. The first is general information, like the location, the operating transit agency, the name of the transit route, etc. And the second is route characteristics. It is mainly related to the physical attributes of the transit route, such as the length and number of stops. And the third type is service attributes. So service attributes are mainly related to the operation characteristics of the transit route. For example, the headways, the operating speed, the fares, etc. And in addition to the variables collected by survey, we also augment our analysis with 3 other types of variables. Those variables are building environment, social demographics, and regional characteristics. Building environment mainly indicate the building environment characteristics along the transit route. So, for example, the population density and the network density. And for social demographics, it mainly included the social demographic information along the transit route. For example, the median household income and average car ownership. The last is regional characteristics, which means the characteristics of the region where the transit route is located. For example, the gasoline price and weather information. So in this study, in this project, we aimed to estimate the relationship between yearly ridership. So here we use yearly ridership for the transit performance. We estimated the relationship between yearly ridership for the transit route and the multiple factors, as I mentioned before, 6 types of variables. So to estimate this relationship, we use a method called gradient boosting decision tree. It's a machine learning method. Comparing to the traditional statistical models, it has several advantages. The first is it is effective in addressing irregularly nonlinear relationships. So some of the relationship between the variables or the factors in the transit ridership might not be linear. So here we use this GBDT method, and then we can try to explore the nonlinear relationship between the factors and the ridership. And this method also has a better performance in prediction, and it can better handle missing values and outliers. So which means even though some samples or observations have missing values and outliers, we can still include them in our study, which means we have more information. We can use more information from our sample during the modeling process. Because it is a machine learning approach, we need to use 2 interpretation tools to translate the result. So here we use 2 tools. The first is relative importance. Relative importance measures the percentage of contribution made by one independent variable among the total contribution made by all independent variables in estimating the dependent variable, which is ridership in this project. So I use the left plot here to conceptually illustrate the idea of relative importance. Suppose this circle here is the total contribution made by all independent variables in estimating yearly ridership. And then we have 3 variables, and each variables will share a proportion of the contribution. For example, variable 1 might share 35%, a variable 2 share 20%, and a variable 3 share 45%. So this percentage actually measures the relative importance. And another feature, another pattern of relative importance is if you add the relative importance of all independent variables, we have 100%. So that is relative importance. And by using the value of relative importance, we will know which variable is more important. So if the variables have higher share of the contribution, it means it is more important in predicting yearly ridership. And the second tool is partial dependence plot. So it simply speaking, it tries to visualize the relationship between independent variable and the dependent variable, but at the same time control the effect of other independent variables, just like this plot. So we can know what the shape of the relationship looks like by using partial dependence plot, which is also known as PDP. So those are the relative importance results estimated by the model. So here we only shows the 10 most important variables. Actually, for the full model, we have 33 variables included in the model, but not all variables are important based on the relative importance. Here we only listed the 10 most important variables based on their relative importance. So among the 6 types of variables here, 3 types of variables, they have some variables are among the 10 most important variables. They are route characteristics, service attributes, and build environment characteristics. And this plot just order the 10 most important variables based on their relative importance. So we know based on the plot, the most 3 important variables in predicting or estimating the yearly ridership is operating environment, number of stops, commence year. So besides those 3 important variables, we know that population density, signal priority, number of parking ride, headway, network density, route length, operating speed, those 7 variables, they also have relatively larger larger contribution comparing to the other variables. So that's the result based on the relative importance. So this is the relationship between operating environment and yearly ridership. So the x-axis indicates the 4 types of operating environment or right of way, which is mixed traffic, semi-exclusive, exclusive, and grid separation. From mixed traffic to grid separation, again, their impact from other traffic becomes less and less. And the y-axis indicates the predicted ridership associated with each level of transit ridership operating environment. So we can see when the level of the operating environment increase to a higher level, and the associated yearly ridership also increase. But the increase is different between different levels. When we upgrade the operating environment from mixed traffic to semi-exclusive, we will have about 70,000 riders increase in terms of yearly ridership. And if we upgrade from semi-exclusive to exclusive, we will have a huge jump here, which is about 3.68 million riders increase in the yearly ridership. So there's no additional benefit when we upgrade from exclusive to grid separation. So, this plot is the relationship between operating environment and yearly ridership. And then we have those 2 plots, which is the relationship of signal priority and the headway. So for signal priority, again, so we have 2 values here, 0 and 1. So this means the transit route with no signal priority. And for 1, it means the transit route with signal priority. So we can see comparing to those transit route without signal priority, the transit route with signal priority will have about 150,000 more riders in terms of yearly ridership. So signal priority do have a positive impact on the performance of the ridership. And then this is the relationship of the headway. So headway actually means the time between two consecutive vehicles. So it is related to the frequency of the service. If the headway is smaller, it means the frequency is higher. So this plot showed that there's two, I think, very interesting results. The first is if we decrease the headway from about 15 minutes, which is here, to 8 minutes, which is here. So there will be about 64,000 riders increase in yearly ridership. But if we further decrease the headway from 8 minutes to 5 minutes, then we will have about 1 million ridership increase yearly. So that's the relationship of signal priority, headway. And then we have those two plots, which is population density and network density. So for population density, generally the relationship is positive, which means if we have more population density, and then we will have a higher yearly ridership, which makes sense. But more information provided here is that the population density, so when the population density is smaller than, so this is about 8 persons per acre, it means that the population density should be larger than, so the relationship before this threshold is flat. It only have effect when the population density exceeds this threshold, which means we should have population density higher or higher enough or large enough to make sure that population density has a impact on the yearly ridership. And for network density, it is the same story here. So we should have the network density denser enough to make sure it has an impact on the yearly ridership. The second part of this study is to estimate the greenhouse gas emission reduction related to upgrading the operating environment to a higher level. So here we use carbon dioxide equivalent emission to stand for the greenhouse gas emissions. So for carbon dioxide equivalent, it includes three types of emissions. The most important one, carbon dioxide, and then we have methane, and we have nitrous oxide. So another note here is that for this study, we focus on the reduced emissions caused by switching vehicle drivers to BRT or LRT riders. So in real world, if we have a new BRT or LRT, and then we were not only vehicle drivers were switched to those transit routes, workers, bikers, and regular bus users, they also were switched to BRT and LRT. However, the proportion of riders switching from other travel modes like walking, biking, and regular bus, the data are not available. So in this study, we focus on the emission reduction caused by switching vehicle drivers to the BRT or LRT riders. And then we use this equation, which is a product of multiple variables to calculate the carbon dioxide equivalent emissions. It has 4 variables: ridership increase, percentage of previous drivers among the new riders, average transit trip distance, the difference in carbon dioxide equivalent emissions rates between driving and transit. For transit ridership increase, we just use our model. We just use the model we have constructed to estimate the ridership for each transit route on the different operating environment. And then we calculate the ridership increase when upgrading the operating environment from one level to a higher level. For the percentage of previous drivers, we got the data from transit survey and a research report. We'll use 25% for BRT and 40% for light rail. And for the average trip distance, we estimate this distance from the 2016 transit onboard survey. So for BRT, it is about 4.2 14 miles. And for light rail, it is about 5.56 miles. And for the emission rate, we will use the data from a national level report. But the national report also provide those carbon emission rates based on the data for the transit route operated by the Met Council. So it is still in the context of the Twin Cities. So those plot shows the greenhouse gas emission reduction. So here we have two scenarios for each plot. We have two scenarios. The first is upgrading from mixed traffic to semi-exclusive. The second is upgrading from semi-exclusive to exclusive. And then for each scenario, we have several routes. So those routes are the transit, the BRT and LRT routes in operating, under construction, and in planning in the Twin Cities. Although some of the transit routes in operation cannot change their operating environment anymore, such as Blue Line, Green Line, A Line, we still include them in our analysis because we hope that the result may help inform future decisions on transit-way planning. And for each transit route, we still have three, we call it electric share scenarios. The first scenario is if there is no electric BRT trips. And the second scenario is if there's 20% electric BRT trips. And the third scenario is if there's 100% electric BRT trips. So based on those two plots, we have two major findings. The first is comparing to upgrading from mixed traffic to semi-exclusive, upgrading from semi-exclusive to exclusive will have much higher associated carbon emission reduction. And for each route, especially for each BRT route, if there's more share of BRT trips are operated by electric vehicles, and then we will have more carbon reduction, emission reductions. So for this study, we have four major conclusions. The first is the right-of-way operating environment has the most significant impact on the transit ridership. So besides right-of-way, several other factors such as population density, signal priority, headway, and network density, they all have large contributions comparing to other variables considered in this study. And upgrading the operating environment from lower level to higher level has a substantial influence on the emission reduction by transit. And last is if we have more electric BRT trips operating on the road, and then we will have larger carbon emission reductions. So we also have four policy implications generated from the results. The first is upgrading to an operating environment with a higher level of right-of-way could substantially improve the performance of transit route, such as ridership and carbon emission reduction. And enhancing the frequency of transit services could boost the ridership. So this is a result, this is policy related to the results of the headway. So if we have smaller headway and then we have much higher transit ridership. If the third is if we locate transit routes in the areas with enough population density and network density, and then we could further improve the performance of transit route. And last one is increasing the share of electric bus vehicles could further decrease greenhouse gas emissions. So that's all for my presentation. Thank you so much.
All right. Well, wonderful job, Tao. Really appreciate you sharing with us here today. Really excellent work and a well-delivered presentation here. We have received a number of questions in the Q&A here. So I'll start with an easy one, hopefully from Mary. If you don't mind launching your slides again. She was looking for clarification on slide number 11. There was a graph showing the relationship between ridership and population density, and wondering what the units of that population density was.
So the unit is the unit is people per acre. So which means specifically it measures the population density in the buffer along the transit route, and the radius of the buffer is half mile.
Excellent. Excellent. Thank you. So after that warm up here, comment from Cliff, or question from Cliff, does the model take into account correlations between variables? For example, route length and number of stops are connected.
Yes, so we have considered the correlation before we include the variables in the analysis. So here actually we have I think more than 45 variables when we started the research, but finally we only included 33 variables in the analysis just because we removed the variables with higher correlation with each other. And the standard of the correlation here we used is 0.6, which is a common standard in this type of research. So yeah, we do consider that. And also the method itself, so the GBDT itself can also try to incorporate the interactions among different variables. So if there's correlations, yes, the correlation will influence the result, but it will not like a nonlinear relationship. So now if in nonlinear models, like linear regression, so if variables have correlations, with each other, and then their significant level will be influenced. But in this study, the relative importance of the variables will not be influenced by their correlations.
That's right. So what I'm hearing there is that when variables are highly correlated, that adding that additional variable to the GBDT doesn't sort of produce additional predictive power. Is that
yes
what you're describing? Okay.
Yeah, that's right. So let's make the simpler. So here we do consider correlations between so if there's correlations higher than 0.6, and then we'll remove those correlated variables. So that's the first thing we address this. And the second is our model, which is the GBDT. When we estimate the relative importance, we do consider if there's some interactions between different variables, and those interactions will be considered, and their relative importance is accurately estimated and will not be influenced by the correlations.
Okay. Very good. Well, I think we'll take time for just one more question here, but I think Tony's question does address, kind of some themes we're seeing in some others here. And he asks, is there a bias problem that we select the best treatments for places with the most ridership potential beyond the specific things accounted for? So this overvalues those best treatments. And I'll admit, as I was preparing, I thought of something similar here. So I'm curious what you would say about that.
For this one, let me think about it. It's a very good question. So let me think about it. And then there is a Q&A after, I think after John Levine's presentation. So I can answer these questions after that.
This is Jason. Maybe I can try to address this question a little bit. And first, when we collect the data from the nation, and we didn't select the best treatment for places. So that means we include the transit routes with the kind of very strong performance, and also with the kind of the poor performance. And also, thinking about for the local agencies, when they try to deploy a new transit route, they often choose the areas with potential ridership. So that means this is not a random corridor, and this is kind of deliberation among different agencies. So I think from my understanding is, we don't see this as a great issue.
Very good. Well, thank you, Jason, and thank you again, Tao, for the presentation. At this time, we'll turn it over to John to bring it home with the final leg of the presentation here. Go right ahead.
All right. Give me 1 second here. I'll share my screen. Let's see, hopefully that's coming across. All right, well, hello, everybody. My name is John Levin. I'm the Director of Strategic Initiatives at Metro Transit, and really happy to take part in this conversation and appreciate being here today. I thought what I would do, in this presentation is really just talk about the linkage and the relevance of this research to our general work at Metro Transit, and then also maybe provide an update on a few of the current projects and how research like this really can influence practice and really support the work that we're doing. I think fundamentally this research, confirms what we understand about the importance of dedicated right-of-way. Let me just figure out how to advance the next slide. The council has actually, I'm going to go back 1 second here. So I just, just to explain this image and kind of our view. This is the Orange Line BRT on I-35W, and so many of you are familiar with this corridor and this route. And I think one of the important elements of looking at the Orange Line here is to understand that I think we understand the importance of dedicated right-of-way. I think we understand that even better now. I think a slide like this reminds us of the practical challenges of implementing dedicated right-of-way. The 35W corridor, from Burnsville all the way into downtown, been in development for bus rapid transit, for over a decade, or maybe a couple decades. And so I think it's important to understand the challenges, the collaboration that's involved, the funding, the cost involved, as well as the patience that's sometimes involved. But the benefits are there, and we see that, in general terms in this research and in specific terms in the 35W corridor and the Orange Line, with the growth in ridership in that corridor with the dedicated right-of-way, and as well as the frequency and the other characteristics of the bus rapid transit line that are there now. So I think this is a great, illustration of what this research really means when it comes to practice. So but I was going to go and just kind of take a step back and talk about what we think some of the mechanisms of this are. And I know that's the topic of upcoming research. But it's really important to think about why do we think dedicated right-of-way leads to higher ridership, or is correlated with higher ridership, or associated with. And I think that we see that pretty clearly, and when we talk to our customers, they tell us loud and clear why there's that relationship. If we look at our 2018 customer survey, on the x-axis here, we see what are the variables that customers think are important. I'm sorry, on the vertical axis, we're seeing what things we think customers say is important to them. And on the horizontal axis, customers are telling us whether they think we're doing a good job or not. So on the left, customers saying that maybe we're not doing as good as we can. And if you look at the kind of top left quadrant, things that are important that maybe we don't do as well at, travel time being reasonable, and the bus or train is on time are right at the top there. Those are characteristics of our service that are directly related to the right-of-way that we're operating in. And when we have a dedicated right-of-way of some sort, we know we can do better in terms of providing faster service, providing more reliable service. So I think our customers are telling us loud and clear, why this research is relevant to us. And I think this also then is reflected in the planning of the council and Metro Transit. So we're taking these lessons that we've learned over the years, and we're applying it to our work. And many of you know that we have a planned network of light rail and bus rapid transit service that we have been developing for a couple decades, and we continue to develop over the next couple decades. And many, if not all of these lines involve some form of dedicated right-of-way, and involve many of the characteristics that have been identified in this research, whether it's frequency, the linkage of the land use, and the kind of how we plan these services. So this is hopefully kind of demonstrating that there's a real tight linkage between what we're doing and what we're seeing in this research. I think it's also important to recognize, though, in kind of looking at this picture, because there is a wide range of types of services that are represented here, and of course, a wide range of types of dedicated right-of-way that was part of this research. And it's not a one-size-fits-all solution. There are different types of solutions in different types of areas, given different levels of demand, given different availability of right-of-way, different funding availability. There's a lot of factors that go into it. And so what you end up with, and it's a little bit getting to that last question that was being asked, why do we, apply different types of technology or different types of right-of-way treatments in different context? And it really does come down to, those types of factors. And in particular, what is the level of demand that often drives decisions around what type of service we're going to provide in a corridor. At the same time, I think what this research also tells us is that once we've made those decisions, it's really important to maximize, maximize our investment in maximizing the exclusivity of the dedicated right-of-way, the dedication of the right-of-way. So, whether it's light rail or bus rapid transit, whether we have bus lanes or whether we have a dedicated guideway for bus rapid transit, for example, wherever we've ended up there, making sure that that works as efficiently, as effectively as possible is a critical element of the engineering, of the construction, of the ultimate operation of those services. So just a couple examples of things that are underway right now. So you can see dedicated right-of-way, sprouting up before your very eyes. We have a couple examples here. This is on the top. This is the Metro Gold Line under construction right now. This is the Etna Bridge, that is, providing kind of much faster, both a dedicated guideway, but also kind of a connection in a place, in a part of the line where there was really not a good connection before. So just kind of an example of how those decisions and that investment, what that looks like in practice. And then similarly, the Metro Green Line LRT, of course, is a exclusive right-of-way. It's a light rail line, but there's even within the context of an exclusive right-of-way, there are design decisions being made that relate to the speed and the reliability of that service. And again, we know that those are the most critical factors that dedicated guideway is driving for us in those investments. The other thing I'll mention is in the earlier slide, we saw that a significant number of the transitway investments are around urban arterials. Urban arterial corridors, really pose a significant challenge when it comes to operating fast, reliable transit service. And so having either that semi-exclusive or ideally an exclusive right-of-way is really important. That research demonstrates it, and I think our observations from all the work that we've done, in the past 15, 20 years has demonstrated that as well. Just a couple examples from the B line, which is in kind of under construction now, I should say. So the Metro B line, will have dedicated bus lanes along a significant portion of Lake Street. This is another important piece of this. Again, it's easy to draw these lines on a map and say there'll be bus lanes here. The actual, development, implementation of these is a lot of work, and it's a lot of collaboration, in particular here with Hennepin County and the city of Minneapolis. There's a lot of different interests that need to be reflected in this work. And so do not take lightly that achieving the kind of the vision of research like this and achieving this in practice takes a whole lot of work, a whole lot of funding, a whole lot of collaboration to really achieve those results. So just another picture, Metro B line, the bus stop treatment with the bus lanes. It's really going to be a fantastic corridor. It's really going to provide a significant improvement in the quality of the service and speed and reliability, which we know will translate into ridership in that corridor. And then lastly, I just want to focus a little bit on, beyond transitways. And again, this is partly reflecting the kind of the evolution of the whole TIRP program from transitway to transit. As Eric mentioned, Metro Transit across our entire route network is looking for ways to improve the speed and reliability of our service. We do that through our Metro Transit Better Bus Routes program. And we look at our service across the entirety of the operation. And when you look at the movement of a bus and the time of a bus, only a portion of the time that a bus spends is actually spent moving people, at I would say a reasonable rate of speed. In this diagram, over 5 miles an hour. A whole lot of time that buses spend out there is moving slowly in traffic, or crawling along, or at stops, or either traffic signals, or boarding and alighting passengers. And so we are looking at the entire gamut of what we can do, not only with dedicated guideways, but also through dedicated right-of-way, but really looking at the entire gamut of what we can do to speed the operation. And I know, for example, TSP came up in this research, and is certainly something that I'll talk about a little bit more in a moment. So, but again, all of these approaches, whether it comes to the signal priority, or queue jumps, or bus only lanes, etc., and they all come with a lot of planning, a lot of cost involved, but they all provide benefit. So this is when you get into really the nitty gritty of research into practice, is when you actually are trying to figure out, what can I do to squeeze out every last second out of the transit routes that we're operating? Because again, we know that the outcomes are more satisfied customers, higher ridership, and better utilization of the transit investment that we're making. So just a couple, visuals of this. Hennepin Avenue, we've implemented bus lanes between the section between Lake Street and Franklin. They aren't 24 hours a day, they aren't the entire stretch, but they do provide a significant benefit. So this is, when you think of the semi-exclusive right-of-way that was described in the research, this is a great example of where that kind of semi-exclusive right-of-way makes a huge difference in a transit operation, cutting minutes off travel time, improving the reliability. This is, just a great example of something that we've already implemented that's made a big benefit. Similarly, the bus lanes on 7th Street in downtown Minneapolis are another great example of where we've been able to really improve the operation with a relatively small investment, but important collaboration, in this case with the city of Minneapolis, to make this happen. And then lastly, I just want to touch briefly on TSP. TSP is pretty complex and not easy. I think the research demonstrated, some modest level of benefit when it comes to ridership from TSP, and I think that would match our observations. It's not a technology that applies everywhere, but when it's done right and done in the right places, I think we find that there's some benefit. It just needs to be done carefully. And the reason I want to show this slide, this is actually a slide of kind of 2 different operating conditions at the same location, but I think they provide just a sense of what we see when it comes to TSP outcomes. Sometimes we really see that benefit, like along the bottom, where the blue curve here represents the reduced travel time through the intersection, compared to the orange, which is without TSP in operation. And so you really see that you see the benefit. On the top, this is a situation where we really aren't seeing the benefit, and this is where we see actually less reliable operations through the intersection, not a significant savings overall in travel time. And so we're really, we do have a pretty significant signal priority system in place and plans in place, but this is definitely a technology where we are looking really closely at where is most applicable, where we get the most benefit. Like so many of the other kind of concept we're looking at here, it's not a universal application, but definitely something where, putting it in the right place at the right time makes a benefit. So that was just a really high level kind of look at, how the concepts that are presented in this research, the application of dedicated right-of-way, what that looks like in practice in the Metro Transit system. I think our research, our customers certainly tell us, what our customers tell us is really consistent with this research. Our observations are consistent. I think this really helps to support and also inform the work that we're doing. So really pleased to see this research and pleased to see that it will be continuing kind of the overall research question of the value of dedicated right-of-way. We're really excited to see the continuation of the research. So thanks.
Wow, thank you so much. This was a fantastic combination of presenters here. So I just want to say again, thanks to Eric and Jason and Tao and John. This was fantastic. So now I'm going to turn it back to Paul again to facilitate some questions and answers. I have a few questions myself, but let's hear from the audience first, and let's dive into this. This is great.
All right. Yeah, well, thank you so much, John. It's really exciting to see how this work can be put to life and how it's being, implemented in a very real way here. So Tao has been typing furiously to answer the questions in the Q&A chat here. So hopefully folks can use the different toggles at the top of that dialogue to be able to see his responses to those questions. However, if you'd like additional clarification on that, by all means, you can raise your hand or type an additional question in the chat here. We do have time for several more questions. Sam, it looks like you may be responding, but I do see several questions in there on sort of another housekeeping item related to how the materials will be shared following the meeting. Can we take just a minute if you would like to respond to that here?
Just as a heads up, the webinar will be posted on the CTS website shortly after this.
Great. So folks will be able to go back not only to see the materials, but also to hear the discussion and the presentations. All right. Well, thank you. And hopefully that provides what folks were looking for there. Anybody have additional questions that they'd either like to ask out loud or perhaps clarifications on any of the questions that Tao and Jason have already answered here? And of course, I'm sure Eric and John would be happy to take questions as well. All right. Well, Lisa, sounded like you maybe had a couple. Why don't you go ahead and get us started?
Well, again, just on my reflection of the two presentations back to back, the research and the research findings, and knowing that those were from areas all around the country, I think some of the survey questions that John provided for the ridership surveys in the metro kind of answered the question about like why, why are the dedicated routes more successful with ridership in particular. But I'm curious, if that would be a next step with research to dig a little bit deeper into the why. And I guess that would probably be more qualitative, right? Getting to some of the kind of reasons why, people feel safer, they trust it more. I don't know. It just that was the piece I was interested in, not expanding that qualitative data to maybe some of the places around the rest of the country. If anybody has a thought on that, if that would be a next step in research, any of the panelists can answer whether that's a thought.
I'm not sure I can speak to the research capacity, but I certainly think that is something that's of interest to us, is understanding, we do a lot of interaction with our peers because we find that their experience, the detail of their operation, but also just what they hear from their customers, how they coordinate with cities, for example, and the right-of-way owners. We learn a lot from that. I mean, I talked about it in my presentation, but again, when the rubber hits the road on this stuff, that's where a lot of the complexity is. And actually achieving the benefits of dedicated right-of-way can be challenging. And so that is also another area that we'd be interested in addition to kind of understanding the customer perspective, understanding that relationship between transit operators and the right-of-way owners.
Thanks. Yeah, and another observation, and John, I know you probably touched on this a little bit, but looking at that whole regional plan, and that's crossing a lot of jurisdictions, right? Counties and cities and lots of state-owned land, and trying to get a continuous dedicated route is an amazing undertaking, right? And it, to show the progress that's been made over the past decade or so, and the planned routes into the future, it's impressive, and quite an example of collaboration.
And we have very complex transit governance in this region. We know that, and very complex transit, the planning. But there's a benefit, there's the upside to that. We have the very close relationship between cities and counties and their residents, and we have the regional perspective of the council and Metro Transit, and you bring those two things together, and I think it's a lot of work, but like you also often end up with being able to build something across an entire region that is responsive to local needs.
Yep, and like you've been seeing with your survey data and your study of the ridership, you can see that, oh, those are more successful routes, but Tao and Jason can show that that's also the same in the rest of the country. So the dedicated right away, when there's enough density and the right land use, can have a big impact.
I also want to add to the qualitative study. I think that's a really good idea. So if we can do a qualitative study to survey the residents across the nation to see how they really perceive, how we really see the dedicated right-of-way, how dedicated right-of-way influence their life. I think that's a very good idea. Before that, I just have a question for John Lavin and probably Eric Lin, because you all have been working in Metro Transit. So has Metro Transit done any qualitative survey in terms of group discussion about the transit service or the impact of transit service in the Twin Cities?
Historically, I know we've done focus groups, for example, trying to understand what people are looking for transportation, and how transit may or may not, meet their needs. So that definitely is an area. And oftentimes we find, one of the biggest factors, of course, driving, folks not to use transit is because is not always the factors you see on the chart that I showed earlier of the customer survey, because those factors tend to be, those are the responses from customers. But, the folks who aren't riding, it's a lot of times, the service doesn't go where they need to travel. But, just in terms of talking to our customers in a more focused way, qualitative way, I know we've had some of those conversations. I mean, we've definitely, through the pandemic and coming out of the pandemic, we tried to have more kind of explicit conversational discussions with customers to get a better sense of that. And Eric, you're certainly welcome. I know you were involved in some of that research before. Certainly welcome to chime in as well.
Yeah, I guess I'd flag two things. One is that even under the auspices of TIRP, there's been prior research, qualitative research, including by Yingling Fan and others, about people's experiences with the transit system, and the mismatch, in some cases, spatial mismatch, other mismatches between how people want to travel and what the system provides. The other thing is the Met Council's travel behavior research program is really a national leader in doing good work and asking the right questions of people about how they travel and how they sometimes, again, would like to travel but aren't able to. So there's a lot of good information out there, and I guess I'll just hold on to the mic one more minute to say that to answer Cliff's first question from a few minutes ago. I just saw you post another, but from a few minutes ago, are there plans for future related research in terms of greenhouse gas impact, incorporating more of this dynamic feedback, where it's not just it's a fixed number of trips and now we assign some fraction to transit, but people are actually rearranging how they move, and maybe in some cases where they live, and how does that build on each other to get kind of a deeper look at VMT reduction and greenhouse gas impacts. That's definitely something that's top of mind for sort of the research frontier. And the TIRP group actually this morning was together talking about what some of our research priorities might be, and something like that was on the whiteboard.
So I've been
Alright.
taking a minute and looking through some of the questions in the Q&A that have been answered, and there's some great questions in there. I don't know if any of the panelists see any of those and want to speak to them a little bit, just so that we can discuss it a little bit, or if any of the people that ask those questions want to raise their hand and do a follow-up or a comment on what you asked about.
So for the second question by Cliff, given the results of this study, yes, yeah, we can build a calculator to estimate the impact for different treatment. Yes, so because we consider not only the operating environment but also like the signal priority, yes, we can do that. So if we, it's just we need to build the scenarios, and then we can calculate on the different scenarios. We can do that.
I just cautioned that we probably can also build a calculator of the costs of the different treatments across different corridors. I mean, I think it's, it is important just again to match, to recognize the benefit of more exclusive, more dedicated right of way, but also to match the investment that we're making to the specific, the geometrics of the corridor, the demographics, the population, et cetera, of the corridor, because different types of service are going to work better in different types of areas.
All right. Well, Tao, I had just one more question I wanted to fit in here. We have another minute. I was wondering, you probably spent a lot of time really being hands-on with the data from all these transit systems that were surveyed. And I was curious if, as you were going through those, you observed any that had sort of like a missing element, some sort of low-hanging fruit that appeared to harm its ridership, where it had a lot of good pieces in place, perhaps like frequency or the exclusivity of the right-of-way or the density, but it was just missing that one thing, whether it was signal priority or frequency or something of that nature. Did you happen to see any of those where, by at least what the data would tell us from the other routes, that by layering that additional element on, it might really have a profound impact?
That's a great question. So actually, in our studies we have a table. So we descriptively studied how the features we have invested perform different for different levels of operating environment. At least, so basically now what we do is we can check the relative importance. So if the variables have a higher relative importance, it means it is more important. So there we see operating environment is most important, and we also see other important variables here. And relative importance is one thing I think we need to consider. And another thing is we need to see if the variables can be manipulated by the transit agencies, because some of the variables, it's really hard to decide by us. For example, we can change the headway, we can change the service frequency, we can change the speed, but we cannot. So some variables like the commence year also has a very important impact on the ridership. If the transit route is commenced earlier, it will have larger ridership, but this one we cannot control. So when we discuss the result, we usually focus on 2 points: if it is really important based on the relative importance, and if it can manipulate by either planners or transit agency operators.
So it's sort of like planting a tree. So like the best time to dedicate the right of way was 10 years ago, but the second best time is today, right?
Yeah, that's right. That's right.
Yeah, that's a great analogy. Thank you. All right, Lisa, we'll leave it to you here if you'd like to field a few more questions, or we want to move on to our wrap up here.
Yeah, if there's no more questions, are there any more in the
Yeah, hand
Q&A that we should? answer those last couple and then we can do the round robin?
Lisa, I see Anna Potter has her hand up. I don't know if we can unmute her.
Maybe in the meantime, I can say a few words regarding the CMS year. For a transit-way program with a longer tenure, and then it tend to, for example, change the land use development along the corridor, and then that's going to affect the transit ridership. And also, we see, when the transit way become more visible, and then more people who like to use the transit, they move into the corridor. So that means this kind of resident sorting will also further influence the ridership. So that's the reason I think the CMS year is really kind of a very important variable in the model.
Sam, I don't know if you can, thanks, Jason. Sam, can you unmute Hannah? Hey, Anna?
I think I am unmuted. Can you hear me?
Oh yeah, we can hear you, great.
I was given permission and this is dangerous, everybody. Sorry about that. Okay, so I think it was John, you had shown the B-line. And that's a corridor through Minneapolis, right? That has dedicated guideway in one direction. So two-pronged question here. How, if you had a corridor like that in your analysis, how would you have coded it? Would it have been in the mixed or like semi-exclusive category or the dedicated category? And then to the Metro Transit folks on the phone, I'm curious your perspective on the compromise that shows that encompasses of, you get some dedicated right of way in one direction, but not both. Not to like put you on the spot, but how are you guys thinking about those sort of situations? How do you pick which direction? Where do you see the agency going with that sort of solution? Thanks.
So let me, I can answer the first one. So when we code the level of dedicated right of way of all the operating environment, we just give the right to the local transit agencies. We already explained very clearly that, so we have 4 types of right of way, and some of the transit routes may have more than one because a proportion of the road segment may have mixed, another proportion may have maybe have semi-exclusive, something like that. And then it's usually we will treat the majority of the transit route as what we have. So for example, if the majority is in mixed mixed, and then we will treat it as mixed traffic operating environment. But still, the local transit agency has the right to code the level of ROW by themselves, because it's really hard for us to check that, right? Because we have so many transit routes, and the local transit agency, they are the people more familiar with the situations.
And to the second half of the question, and specifically to the B-line and the nature of that, I'm not intimately familiar and wasn't directly involved in the planning and the design there, but I do know enough to know it's a very complex situation with a lot of negotiation. So I probably won't kind of get into the specifics of that. But what I do think is that what the research shows us is it helps us to understand and explain the value of the more dedicated the right of way you can provide, the better. And so when we are in those negotiations, whether it's B-line or any future corridor, I think bringing that to bear into the conversation is really important, because the transit customers, the ones who responded to that survey, who are going to benefit from that faster, more reliable service aren't in the room. So the research almost is a proxy for their voices and what they're looking for from the service that's being, the transit way that's being developed, the service that's going to be operated. So, but I do know they're complex discussions. They have involved a lot of different factors from a lot of different stakeholders. I think we would advocate, of course, for having as much dedicated right of way as possible, but there are trade-offs that are made. And hopefully research like this will just continue to help us to make the case for making those decisions in the direction of more dedicated right of way whenever possible. So not much of an answer, but just to recognize that it is pretty complex.
Great. Well, thanks everybody for the presentations and the Q&A. And the last couple minutes here, I'll do a abbreviated round robin. I want to stress one of the most important things that the councils do for CTS and for the Transportation Research Program, and that is to try to develop problem statements for future research, right? I mean, and we've got practitioners here and people from the academic community. So it's a chance for all of us to kind of throw ideas out there. So if people can put in the chat, are there any issues facing your work these days that you'd love to know more about? And maybe someday those will turn into problem statements. I know one that's on my mind is I'm really interested to see, you know, we've got all this reconnecting communities funding and especially reconnecting communities planning grants and nonprofits and communities are eligible to apply for those grants. So what's going to be the impact of that on projects in the future? Now, that's not maybe a problem statement we can study today because no projects have been built from that, but that'll be a future research topic that I'm interested in is, you know, how does that change how we do planning and how does that change the outcome in projects? So that's something I'm interested in, and people can raise their hand, we can unmute, or you can type in the chat if you've got any issues you'd like to learn about that maybe the research is the best way to get information on. And like I said, it's one of the most important things for the CTS research councils to do is to come up with problem statements. I'm not seeing anybody type anything in the chat. Paul, do you have any ideas? How, anything else you want to study? What's their next problem statement? John, anything you want to see studied that you're not already looking into in your surveys?
I see something from Mary in the chat now.
Oh, you do? Okay, maybe I didn't scroll down far enough. Oh, I don't know why I'm not. If somebody
I think it's in the Q&A.
Oh, in the Q&A. Thank you. Sorry, I was looking in the wrong place. So Mary's saying that a team of folks she works with are all wondering if we can build better predictive models based on existing data for pedestrian bicycle activity. Yeah, that would be a good research project. And years ago, I was part of a team that wrote a problem statement to learn how to count bicycle and pedestrian traffic. And, you know, that was over a decade ago. So now maybe we have enough data to build a model, right? So, because we've been counting the bike and ped traffic for a while. So yeah, that's a really good one. We'll make a note of that. And when we're next round of research needs statements, we'll try to find a champion and put that one in. Good idea. All right, well, 1 minute's passed, so I see a few people have already signed off. I don't have anything else. Thanks everyone for coming. Thanks to the presenters. Thanks to CTS. Thanks, Mary. Thanks, Paul.
Thank you.
Good night. Thank you all.
Thank you.
All right. Thank you.